Today we're doing momentum in 2 dimensions, conservation of momentum. So we're doing part C, and we're doing problem 18. So I'm going to do like I always do. I'm going to write my given and my find. But in this problem it's going to be a little bit different because we're going to have 2 pictures. So I'm going to read, so it says a 6 kilogram object, A, so that's going to be MA, is 6 kilograms, moves at a velocity of 3 meters per second. So VA is 3 meters per second. It collides with the second 6 kilogram object, so MB is 6 kilograms, at rest. So VB is equal to 0. So before I go on, I'm going to do what I call my what's happening picture. What's happening? So what I'm going to do is I'm going to draw, here's ball A, and I'm going to use this to represent, this arrow is going to represent the momentum of ball A before collision. And it hits ball B, which is stationary. So that's the beginning of my what's happening picture. So then it says after the collision. So in physics, we always have to have a frame of reference. And my frame of reference is usually where motion begins. So because momentum is a vector quantity and it has both magnitude and direction, as far as my reference is concerned, the reference has to do with the original direction of ball A. So what I'm going to do is I'm just going to draw little dashed lines to show this is my frame of reference, the original direction of ball A. And if I actually read the next sentence, it says after the collision, A moves off in a direction 50 degrees to the left of its original direction. So this is ball A's original direction. So what I'm going to do is I'm going to do now a different color because this is after my collision, and this is ball A after the collision, and this vector represents PA prime. This is the momentum of ball A after the collision, and again, I'm going to draw this 50 degrees from its original direction. All right. Ball B moves off in a direction 40 degrees to the right of A's original direction. So here A's original direction. So I'm going to draw this. Here's ball B. And this is PB prime. So this is, again, my what's happening picture. Again, this dotted line is the original direction of ball A, which you don't have to write that in there. I'm just showing you in case you go back and look at your paper and you want to say, why did I draw that dotted line, that dashed line? All right, now, conservation of momentum says the total momentum before is equal to the total momentum after. But remember, momentum is a vector quantity. So the total momentum before is this, the momentum of A. Okay? So I could actually calculate it. I'm not going to do it now, but we know that PA is equal to MAVA in this direction. And then the total momentum after are these 2 vectors added head to tail. Okay? So this is equal to these 2 added head to tail. What I'm going to do now is, and you have to do this for all your problems, you're going to draw what's called a momentum triangle. Okay? So I'm going to start off first, and I'm going to draw the total momentum before. So what I'm going to do here is I'm going to draw this is equal to PA. Now I can calculate PA because I know PA is equal to MAVA. So if I do that, 6 kilograms times 3 meters per second, so PA is equal to 18 kilogram meters per second. And that's the total momentum before. Now, these two added head to tail have to be the same. So what I'm going to do is, this is where I start. So all I'm going to do is draw a PA prime just the way I see it. So at 50 degrees like this is PA prime acting at 50 degrees. Now, we don't have time to do a whole geometry lesson now, but I'm just going to go through real quick. Remember, I want to draw this vector head to tail to the other. So what I'm going to do is, I'm just going to, on pencil, I'm doing a little imaginary line to show the horizontal. And remember, this line, this vector has to be what? And I forgot to write it in there. This vector is 40 degrees below the horizontal. So now here's my horizontal. So this vector here, which is PB prime, this angle here is 40 degrees. Now, back in the day, we learned something called alternate interior angles. So if this is 40 degrees, that means this is 40 degrees. Okay? Now, obviously, when I look at this, if this is 40 and 50, that's 90. All triangles have 180 degrees, which means this is a right triangle. At this point, I'm kind of done with physics because this is super easy. So the problem now said, and I didn't write, it said draw your momentum triangle, which is this. That was my momentum triangle. Then for part B, and we have to add in because I had a typo, you're going to find the momentum of ball A after the collision, the momentum of A and B after collision, and then you're going to find the velocity of A and B after collision, which I didn't write on there. So you're going to find VA prime and VB prime. So I'm going to do all that stuff. Now, how am I going to do that? I have a right triangle. I know all the angles, and I also know the magnitude of the hypotenuse. Can I find the other two sides? I can. Now, is that physics? Math. Should I use sine? Should I use cosine? What should I use? Doesn't matter. What pops in your head first? For me personally, the first one that pops in my mind is sine. So I'm going to write sine of theta is opposite over hypotenuse. So pick a side. So I'll say sine of 40 is equal to opposite PA prime over the hypotenuse, which is 18. So PA prime is equal to 18 sine of 40. And when I put that in my calculator, it comes out to be 11.57 kilogram meters per second. Now when I want to find PB prime, and I forgot the prime here. When I want to find PB prime, remember that it's a right triangle, so I could use the Pythagorean theorem and say this squared minus that squared is this, or I could do the same thing, right? So, or I could use cosine. So since I already did sine, I'm on that sine roll, I'll just do the same thing, and I'll say sine of 50 degrees is equal to PB prime over 18. So PB prime is equal to 18 times the sine of 50. So PB prime is equal to 13.79 kilogram meters per second. So now I've already found that part. So this and this was not physics, that's math. So I used my momentum triangle to find the other two sides. Now I want to find the velocity. So now I'm going to go back to the first thing I learned. I'm going to say P is equal to mv. So I'm going to say that PA prime is equal to ma times VA prime. So I'll rearrange the equation to solve for the unknown in terms of the known. So VA prime is equal to PA prime over ma. So it's equal to 11.57 kilogram meters per second divided by 6 kilograms. So VA prime comes out to be 1.93 meters per second. And don't forget about my units, because this kilogram is going to cancel with that, and I end up with for meters per second, which is my correct unit for velocity. So in physics, I always have a foolproof way to check my work every single time by carrying my units through and canceling them. And I don't have to pull it to the side, I can do it right there. And now I'll find VB prime. So VB prime, and I could do the same thing. I could start off here and say PB prime is equal to MB VB prime. And then VB prime, I didn't give myself enough space there. VB prime is equal to PB prime over MB. So it's 13.79 kilogram meters per second divided by 6 kilograms, and that comes out to be 2.32 meters per second. And again, my kilogram in the numerator cancels with the one in the denominator, and I end up with the correct unit for velocity. So when we did this problem, we don't just start writing down numbers and equations. Obviously, having a picture is going to help us. So when I'm doing this problem, what I'm going to do is I'm going to start off with my what's happening picture. And I'm going to say the total momentum before is equal to the total momentum after. But momentum is a vector quantity, so I have to add it head to tail. This is my total momentum before, which is these two head to tail. I have a right triangle. I find the other two sides, and then I say momentum is mass times velocity. Really, really, really not that bad at all. But when I do it step by step, I don't make a mistake. That's it.